So alternative dosage calculations methods. In this course, we've talked about dimension analysis. We talked about formula method. Ratio proportion, we just talked a little bit about it. We don't use a lot of ratio proportion, but every now and then you'll find it's instructor that will like the ratio proportion. And I'm going to just skip ahead to it right quick. We're still going to use the 3-step approach, which I say this should be 4 steps. The first one's convert, second one's think, third one is calculate. I say that we need a 4th one that actually says rethink. Just make sure before you give the drug. A ratio of proportion, though, is where you take, and a ratio is a fraction, guys. So you're going to take a fraction. And we're going to ask ourselves, what is its equivalent to? You know, is it equivalent to this side? Well, usually we have one part we're solving for. In this case, it's the amount. So what you do is you take what you have on hand. This is our available. This is our supply, right? It's our dosage on hand divided by the amount on hand. Okay, so that would be milligrams per tablet. And we're going to set it up equal to our desired. So this is usually the order, right? Divided by what we're solving for. And this equal sign says we're going to have to do cross multiplication to solve this. So this is ratio proportion. If you want to use this method, it's fine with me. Just be very, very, very careful. And if you're ever asked to solve it using dimensional analysis or formula method, you need to be sure to be able to use that as well, okay? So this section here is just a quick review of how to solve. So I'm going to solve it. I'm going to solve it using all 3 methods. This one particular problem, it's a really short video, just so you can see the setup. Okay, so what do we have here? We have an order that says 0.6 grams of IV every 12 hours. And then we have this supply of 300 milligrams per 2 milliliters. Well, guys, what I noticed is my unit on the order versus my unit on the supply, they're not the same. So I need to change this one here to get the units to be the same. And what do I know about the relationship between grams and milligrams? I know that for every 1 gram, that's 1,000 milligrams. So I'm going to go ahead and set this up. And I'm going to go ahead and just convert it and be done with it. And then we're going to, and you can use all 3 methods on just this simple little conversion here as well. But I'm just going to go ahead and solve it right quick. So I'm going to use dimension analysis. And trying to get through this right quick. Okay, and what I did is I said this one order, that's a terrible looking one. It looks like an L donut. See, this is why I say be very careful about what we write. So it's over 1. And I'm able to go, oh, that gram reduced with that gram. And we know the relationships between the milligrams and grams is 1 to 1,000. So I'm going to have 0.6 times 1,000, which is going to give me 600 milligrams. Okay, now that I know this, right, I'm going to write it right here so I can erase some of this other. Okay, so now that I know this, I'm going to erase this guy. So if you need some time, pause it and write it down. So I'm going to erase it. All right. So now let's do our first step. Let's do the dimension analysis, okay? Well, dimension analysis says take the order. I'm going to put a 1 underneath it because I'm visual. Some people won't need to. And then let's take our supply. We have 2 milliliters over 300 milligrams. We're solving for milliliters, so that's why it needed to be on top. Plus, we needed the milligrams to reduce, right? So one has to be on top versus the other, and we always put the order on top. So now I have 600 times 2. And I'm going to save myself some extra work because I see something. I see that 300 and 600 reduces. So I'm going to go ahead and reduce that right quick. I know 300 goes into itself once and goes into 6 2 times. That leaves me 2 times 2, which is 4 milliliters. So that's my answer, and I solved it in dimensional analysis. Now let's come over here and solve it using formula method. Formula method says take our order, and we're going to divide it by our half. Our half is 300 milligrams times 2 milliliters, my quantity. And let's divide it. 600 divided by 300 is 2. The milligrams reduced leaves me with 2 times 2 milliliters, which is 4. And now let's do ratio proportion, just because some of you may want to see it. Do not have to solve it this way, but again, you need to know how to do the formula and dimensional analysis if you're ever asked to do it. So let's go back. It says we're going to take our dosage on hand, divide it by our amount on hand. So our dosage on hand is 300 milligrams, and our amount is the 2 milliliters. Now we're going to set it up equal to our desired and divide it by what we are solving for. And you can use X if you want, but if you're using X for multiplication sign, you need to be careful to use it here. You can call it A for amount, whatever you want to call it. So we're actually solving for milliliters. So what we need to do is we're going to have to cross multiply. So now I got 300, whoops. I got 300 milligrams times X is equal to 600 milligrams times 2 milliliters. Now I need to solve for X, so I'm going to divide this side by 300 milligrams. Right, and now I can mark through my mg, and my 300 goes in itself once, goes in 600 2 times. 2 times 2 milliliters is 4 milliliters. And that's using all 3 methods. And it's all about the setup. So this section, please review it. If you have any questions, please ask me. I'm here to help you. Thank you.